let me start the webinar, which focuses on fair and transparent data policies and artificial intelligence applications. So I hope I am clearly audible to all of you. If there is any communication problem in either side, kindly raise it. So as we know, and you all are familiar, that India's rapid digital transformation has created one of the world's richest and most diverse data ecosystems as on date, from Aadhaar and UPI to large-scale health and education initiatives. In fact, we all in this country have become like pieces of data in our Aadhaar database. And this is perhaps one of the biggest digitization drives that the world has ever witnessed. So this wealth of information provides a unique opportunity to develop artificial intelligence solutions tailored to the country's needs. But it also raises very critical concerns about fairness, transparency, and accountability. In our country, historical inequalities relate to caste, gender, region, and economic status, and that can easily, crawl into the data. And if left unchecked, AI systems may reinforce rather than reduce these divides. So ensuring fairness requires deliberate attention to the inclusive data collection, unbiased sampling, and of course, careful validation of the algorithms against diverse population groups. That is why modern time AI developers or AI practitioners and our younger generations that are going to be the professionals of the country must be aware of the AI auditing systems in India and their focus on the transparency, reliability, fairness aspects of the next generation AI systems. So with this background, let me share some of my thoughts and some of the concepts that relate to the modern days artificial intelligence systems, as well as their growing needs in industrial sectors, from the perspective of this fairness and transparency. So nowadays, what is going on under the name of artificial intelligence is actually deep learning. And deep learning systems, which are somewhat very loose sense, a mimicry of the human neural networks, connections of billions of neurons residing in our brain, our cerebellum, etc., cerebral cortex, and so on. These systems, their biggest selling point is that they provide context-aware, optimal representation of data, followed by some downstream tasks like putting the data into the right category, identifying certain objects from a complicated big picture, or identifying the speaker from an audio, identifying or authenticating a person from fingerprints, and so many such aspects are there. So first of all, if you look at figure A in this particular slide, we have inputs. These inputs are data items or data. What is this data? Data is nothing more than an abstraction of any real-world object around us in terms of certain numbers sitting together. When I go to a bank and ask for a loan, I become a piece of data. The bank starts specifying me in terms of my credit rating, CIBIL score, and other financial parameters. These numbers that collectively define my existence in the bank are called features. And there has to be a human expert who will say what are the right numbers that specify this particular object. After that, there is a statistical mathematical system, an algorithm, or a computer program in simplest form which will put me in a right category, whether loan should be granted to me or loan should not be granted to me. This task, this categorization task, is usually called classification in machine learning jargon. Deep neural networks do not require this human intervened representation of real world objects in terms of the most informative higher level features, not just the measured ones. So you see, if you change the context, the numbers that represent you or the parameters that define you will also change. Instead of a bank, if I go to a blood bank and I try to become a potential blood donor, then the blood bank starts specifying me in terms of whether I have thalassemia, what is my blood pressure, what is my age, all these medical parameters, and then it will put me to one of the potential donors or restricted, prohibited donors. Okay. Deep neural networks can sense the context of such categorization tasks, extract most suitable features, or learn the most optimal representation, and then it performs such downstream categorization task or detection task in a very righteous way. That is the major, biggest selling point of deep learning, which forms the backbone of all modern AI systems that you see all around you, including ChatGPT, Canva, Meta AI, Facebook, everything, everywhere you can see at the back end such big deep neural networks. And as I told you, AI feeds on data. What is data? Anything around us which you can abstractly represent, store, and process by a digital computer in terms of certain numbers sitting together. There could be only one number, in which case I will say it's a scalar data, like the average daily temperature of Kolkata or Bangalore. There could be groups of numbers also, as we will see. So the AI, if you look at AI as an engine, then data is the most critical fuel on which that engine runs. Okay, that's why, just like for your expensive car, you would require properly filtered oil. Similarly, for AI systems to give you flawless results, you will also require properly cleansed, balanced, appropriate, and safe data. That is where the context of this talk comes in. So, and just a moment, yeah. So the earliest known documented data, one of these such data is the iris flower data. Iris is just a flower like our rose, etc. And there are three scientific classes within the iris flower: versicolor, setosa, and virginica. So long back in the late 1890s or so, Ronald Fisher, who was a pioneering statistician, and their team, including some botanists, first abstractly represented such iris flowers. At the time, the concept of computers were not known. But what they did is they sort of took 4 measurements on each flower. And these measurements denote the length and width of the petal and those of the sepal. So these 4 numbers started to specify each iris flower. Every flower became a vector of 4 numbers sitting together. Just as in physics, you have seen vectors X, Y, Z coordinates come as a vector denoting the location of a point. Similarly here, these 4 numbers together express abstractly each flower. Okay, so every flower, which is a real world object, becomes a vector of an array of 4 numbers. These measurements are also called features, attributes, and dimensions in various different fields. And therefore, each flower becomes a piece of data. Similarly, when we have an image, okay, full of pixels, this image is like a 2-dimensional array or a matrix. Okay, we can have stacks of image, color image, where we have 3 different matrices recording the intensities of that color image in red, green, and blue. These 3 primary colors. All other colors could be born by appropriately mixing these three primary colors. Okay, so in that case, this colored image is like 3 pages of a book, which we call a tensor. Similarly, we could have a graph, each node of which is a vector or a tensor, something like that. And each node is some user who, in a social media platform who is connected to many other users. Now, after almost 130 years, data no longer remains as simple as IDs, flowers data. Now every Facebook profile is a data item, and that is highly heterogeneous in nature, containing, image, text, video, everything. And this Facebook profile is not only that, like every human being is a set of connections. Okay. All of you are sets of connections. If you don't go to your institute or school or college for a few days, your friends will visit the house. So every such Facebook profile is linked with many other profiles. Sometimes very frequently they are communicating, sometimes less frequently. So that's why we visualize this entire social network as a graph, which is a mathematical structure very common in computer science and discrete mathematics. And each node of the graph is a profile, and the links are basically the communication modes between different profiles and so on. Okay. This is just a modern representation of data acquisition system where we see how an AI system could do route optimization, demand forecasting, optimized procurement, and safety enhancement for the passage of oil from oil refinery to fuel terminals to gas stations. It's a big network, actually. Any Bharat Petroleum or Hindustan Petroleum, all of them have this refinery to fuel terminals to gas station road networks, which needs to be optimized on real time. And previous past data in this context would be acquired from all these refineries. How many tons of oil are going out to which location per day, and which time of the day the demand is picking up, all these things. Therefrom, the AI system can do most optimal prediction of routes, how many trucks should be employed on a particular route, how we can enhance the safety in especially so that there is no explosion in anywhere, because these oils are highly combustible substances and so on. So all these real world needs are fulfilled, provided the right data flows into the AI system from diverse, different, sources. And the data can have also diversified natures. Modern AI systems can very easily, destroy the existing structure of the data, put it in any other form, from tabular to graph to a frequency, bar diagram, histogram, anything. So multimodality of the data coming from diverse nature. Some are images, some may be tables, some may be something else, some audio. All these diverse modalities could be very well addressed by the modern foundation models that prepare the background of this AI. So you now must have realized that AI today does not just predict the trends or recommend the movies. It makes decisions that affect people's life. Like I gave you example, who gets a loan? Which patient gets prioritized for treatment in a healthcare management system? Or how public resources are distributed, like these oil refineries and so on. So this brings enormous opportunities, but also significant risks: bias, unfair treatment, lack of transparency, and potential misuse of data. All these things can come. So let me just try here. So traditional artificial intelligence systems, they were task-specific and isolated. You need to classify between loan, whom to be the loan granted and who will be refused. So borrower classification system in any financial bank, or perhaps one person has pneumonia or not from the chest X-ray images. These are, for all these tasks, you will develop a standalone AI system, which is in like an use and throw system. You will develop it, you will test it, you will deploy it. Once the purpose is served, the system could be discarded. Then gradually people realized if we build up bigger systems, AI systems, which have more, complicated architectures like the deep neural networks that were conceived by, loosely imitating the human nervous system. So such networks, if they are trained on a particular task, now I use the word trained, which means if they are shown lots of example data and they are right categories marked by some human expert, that is the training process. Show it many, many examples. Like when you go to a class, your teacher solves many worked out examples in the class from a particular chapter of the book. And then in the exam, you will be facing unseen questions from the same chapter, which you need to now answer. Okay. So based on the experience that you gather from by looking at these worked out examples, you will apply them to the unseen examples. Now, people realized if a big machine learning system like the deep neural networks, they could be trained on a particular type of task, they can gather experience, and then instead of discarding that system as a whole, we can reuse that system with very little change to carry out another task. When we go into our professional lives, all of you who will be entering into a good career, you will first be solving certain tasks and in a particular concern or company. After solving such tasks, what you will gain apart from money? You will gather experience. And with the help of that experience, when you go to the next higher position or higher company, you will be solving more intricate tasks. You will gather more experience. Gradually, that experience will enrich your professional career. Similarly, transfer learning gets into that. A neural network which is trained to demarcate between, big trucks versus small cars, tempos, small, this carrier vans and so on. Such a neural network could also be used at the back end of a camera, which is fitted in a restricted forest. And for the highway is there on the forest, the camera captures the elephants crossing the highway versus the deers crossing the highway. So the neural network is already trained. It knows how a big moving entity like a big truck versus a small moving entity like a small van looks like. So with that experience, it can also almost with very high accuracy demarcate between these elephants versus small deers on the pathway and mark their positions as well. That is transfer learning. And then we are in the era which is known as the era of foundation models. We have huge, big neural networks. All these are, by the way, neural networks. Massive multitasking networks, which are trained on huge external amount data. For example, if you, I'm sure all of you are using ChatGPT in some form or some other form. So systems like ChatGPT or Meta AI, they are trained on almost on the entire internet. Okay, massive external amount of data is there. And then they could be fine-tuned for your specific task by using small amount of proprietary data. If the machine has this machine learning algorithm has a big experience over diverse and huge amount of data with high veracity available on the internet, it could be very easily fine-tuned or adopted for your company specific task. This is the way of developing a new business idea from ChatGPT-like models. For example, you can very easily fine-tune ChatGPT to create a number of slides from a blog. So you give a blog post's URL, paste it in the ChatGPT. It's not fine-tuned like that in general, but you can do it and you can start a new business, turn blogs into slides, or give your websites or give your CV and ask it, develop a PHP-based website for me. So I want an URL. I have a CV. You extract the information from the CV and make it URL. This is fine-tuning. And for this, you will need to show it little bit of what you want, little bit of examples, data from your end. There are various ways of doing that, and all businesses are running like that. The massive foundation models require huge amount of computing, which is way beyond most of the companies in India. That's why OpenAI, Facebook, Meta, Google, they are coming forward with such foundation models as platforms, and we are mostly fine-tuning. That's a different story. But this foundation model means it's a huge model with multiple inputs and multiple outputs, various diversified outputs, question, answer, translation, paraphrasing, asking for new information, summarizing. You do all these stuffs with ChatGPT. ChatGPT at the back end of it, now you can see GPT-5. Okay, generative pre-trained transformer 5, version 5. This GPT-5 is the foundation model. It's a jargon to denote the machine learning model. So we are going from task-specific models to transfer learning to foundation model. That's where we are now. For example, the SAM, segment anything model, is a transfer learning model. You input any image into it and you just write cat with black ears. That means you want to segment out the cat which has black ears, and it will provide this sort of an output where the cat is segmented with black ears. This is a segmentation foundation model in computer vision. Similarly, large language models could also be fine-tuned. The LLMs, or large language models, are also foundation models which are specifically trained to, act on text and image and speech type data. For example, GPT-3, 3.54, now 5, all these are LLMs or foundation models from OpenAI. All LLMs are foundation models. And they nowadays can work on huge amount of text, image, speech, whatnot. They are designed to understand and generate human-like language. And you can always think of them as virtual assistant that can read, write, or comprehend text just as a person would, but much faster and on a larger scale. And you can fine-tune them. For example, PaLM, which you can see here, is a PaLM 2, Pathways Language Model 2 from Google, is a huge, large-scale general LLM, general-purpose LLM. It's like an encyclopedia. It's trained on the entire Wikipedia. But you can make it expert in medical prediction, diagnosis, so the images that you can see on the right-hand side are from MedPalm 2. You can upload an image and ask, can you write me a report analyzing this chest X-ray? And it will immediately say, okay, findings, lungs, no pneumothorax, no substantial pleural effusion, and so on. Just like a lab expert, it will write you down the report. That's where we are going. So this is a medically fine-tuned version of LLM. Similarly, we now have GPT-4, 5. These are all called VLMs, actually, vision language models, where you can upload an image and you can do a variety of things. For example, object localization. If you say, is one cat behind another, after you upload this image, it will say, yes, one cat is behind the other in the image. The cat in the back is facing the camera, while the cat in the front is facing away from the camera. You can say, okay, segment me. That means specially point me out the striped cat. And this is the result. Both cats are striped. Similarly, then you can ask, what is the breed of the cats? Or you can give some examples and then ask, that is called one shot. It will do all those stuff. And AI, similar foundation models are going into solving IMO problems. IMO stands for International Maths Olympiad Problems. And for example, this alpha geometry, you can see its result is very close to the Math Olympic gold medalist's result. This paper came in Nature in 2024, and it has a symbolic engine which could actually bring out several very interesting results by symbolic reasoning and so on, and solve abstract geometrical problems. Anyway, so these are about the developments that we are looking at and all around us. Now there comes the need of the hour, responsible AI, that has to be fair, transparent, and accountable. Then we can actually trust it. The trust of different domain experts like the doctors, the engineers, and other people on the AI system stems from this responsibility, sense of responsibility that has to be in them. And the first step towards that is fairness. Fairness means fair AI is something which is not unfair. What does that mean? That means it will not give undue favor to any demography, any group, any particular domain from which the data originates. It will treat all data items in an equitable, unbiased way. Okay. Then we have, say, for example, the interpretability, which says, okay, the AI system, how it maps its inputs into the outputs for a large, vast, diverse data sets, that has to be understandable, okay, so that people could know how it is reaching its decisions directly. And then there comes the explainability. Explainability and interpretability are not the same. Most often, the best explainable AI models may work on certain input instances. So for example, I give this chest X-ray image to my AI model, and it should tell us the patient has 97.6% likelihood of pneumonia. That is the prediction from this AI model. It's a diagnostic model. So I need to understand, as a doctor, suppose I'm a doctor, I need to understand which portion of the image the AI is concentrating, looking at, and based on what sort of anomalies it is saying the patient has a high likelihood of having pneumonia. If that insight matches with the clinical intuitions of the doctor, then the AI is perfect. It's doing a very nice job. So explainability means understanding why, for a particular input, the model is providing a particular inference, based on which portions of this input this inference is reached. So once again, fairness means models should not discriminate against any gender, caste, religion, region, demography, etc. Transparency means people should understand how decisions are made. That's about the interpretability in other terms. And explainability, as I just said, particular decisions reached by the model must be properly understandable. Accountability comes following all this, where institutions must take responsibility for the outcomes and not shift the blame to the algorithms, which is nowadays a very big problem. So alongside comes, of course, the transparent data protection measures, and India's digital, Personal Data Protection Act in 2023 for business is being hugely upholded in different concerns. First of all, before even we think of AI models or build AI models, we must ask this question: how the data is collected. Ethical data collection requires, first of all, informed consent from individuals. Individuals at the user end needs also to be educated about this. We should not click on a box to have some freebies on internet and then let the back-end company use all our photos, videos, personal chats, etc. That can put us in great danger. So informed consent from individuals, transparency about their data, how their data will be used, protection of privacy and security of the data. That's why proper anonymizing must be there. And No disclosure of personal attributes has to be there. Avoiding exploitative or biased sampling practices has to be there. For India, where the data comes from diverse communities and contexts, respecting cultural sensitivity and inclusivity is especially very, very critical. So we can see how we can safeguard you. So these are the components of, Indian digital personal data protection. For example, minor consent, guardian approval for processing data of minors and physically disabled, appoint data protection officer for enhanced security transparency, especially in government institutions where common people's data are being used. And controlled transfers. Central government will oversee the data export beyond India. Rapid breach alert, hefty penalties on not obeying these rules, and fair appeals. So these are some of the components of this Data Protection Act that is being imposed. So I will skip some of the technicalities, but unfortunately, let me just tell you this. Nowadays, we have several machine learning models around us for different purposes. Most often where we use image, speech, or some other complicated form of data like graphs, etc., we use deep learning. For tabular data and in financial sectors, we mostly use ensemble classifiers like the boosting machines or random forests as bagging ensembles and so on. The tragedy is the more is the prediction accuracy of the model, the more black box it is. So when you have a huge trillion parameter neural network, which is like this GPT-5, this network, how it actually processes the data, it is so complicated. It's like a huge mega factory with several trillions of connections. And how these connections are processing the input to transform it to the output, that remains pretty undisclosed and almost not tractable. That means their explainability, transparency aspect suffers. So there are many ways of making these machine learning systems more accurate or interpretable. There are many auxiliary aspects by which their explainability could be enhanced, keeping their prediction accuracy or their usability very high. I'm not going to discuss such technicalities in great details here, but especially in medical AI, when it comes to India, especially in medical AI and in many other cases also, algorithmic biases in AI systems, which mainly stem from the data, becomes a very big problem. Medical, healthcare is the area which which could be greatly benefited from the AI/ML systems, because we have so many patients in the outpatient departments of our hospitals. Our doctors are most often overloaded. Okay, so given having said that, definitely for initial diagnosis, for patient waiting time minimization, for hospital management, and AI could be a game changer. But at the same time, if you look at the key statistics, you will see that skin disease detection, for example, is very much dependent on whether the person is from a Black ethnic group or a colored ethnic group like us, or from a white ethnic group like the Europeans, Canadians, US, Americans, and so on. So depending on the demography, if your training data, example data is just on the white-skinned people, it will not work for an African demography or an Indian demography, most likely. Similar instances are everywhere in medical AI. The bar for detecting pre-diabetes or diabetes and the corresponding treatment that you may suggest will vary for an African person to an Indian person to a Chinese person. tradition, so I will skip some of this. Traditional approaches to explainability, for example, the AI system should actually highlight the region in the original image, and nowadays there are various auxiliary ways to do that. So when the AI system says this image is a tree frog with high percentage of chance, like 54%, where it concentrates on this facial part. It neglects rest of the part of the image, and depending on the facial part, this is the explanation why it says, okay, there is a high chance that it becomes a tree frog. Similarly, nowadays, these deep neural networks could be probed and could be highlighted the regions based on which the neural network will say, okay, there is a cat in the image and there is a dog in the image. So you can see these are the regions based on which this will say it. Similarly, in clinical images also, when we say we are classifying the cerebral images into cognitively normal or Alzheimer's disease, ADs, or mild cognitive impairment, which region of the cerebellum is forcing the AI system to take those decisions. These heat maps in blue shade show you those regions. These are various ways of explaining your decision. But I will go to something. So this is another one of our work which simplifies the medical reports generated from a medical AI system by using another round of fine tuning through chained prompting system. This is just for an illustration purpose. Medical reports that are generated from medical LLMs or even from doctors are full of medical jargons. So they are not directly usable in a telemedicine network. It will say, okay, no focal air space disease, pleural effusion or pneumothorax, cardiomediastinal silhouette is within normal limits, etc. You have to, then our system, the system which is proposed in this paper, you can see at the bottom, this paper simplifies it and it says there are no areas of solid lung tissue, no fluid in the lungs, no collapsed lung. The size and shape of the heart and surrounding area, which is basically the cardiomediastinal silhouette, they appear normal. So this is a system which simplifies the medical reports to communicate with people who are not expert in medical sciences. That means common people, the patients like you and me. So that's it. Now there comes the bias and fairness issue, which is, as I said, the most important thing. There are various forms of bias, and why it is so? Mostly because the gatekeeping is always done by those who are in power. So people who collect data, who procure that data from their own country, and then create a system which is like a platform used by all other countries in the world, naturally that system will be biased towards the demography of that particular country. So bias, there are several ways in which bias can come. Bias in the data could be because of historical inequalities embedded in the data sets. Bias in the algorithms could be because the optimization goals of those algorithms are ignoring the fairness. Bias in deployment could come because of unequal access to AI technologies. All these forms must be well understood for our young professionals or young people who are going to be the future and must be becoming the stakeholders of such huge AI platforms in few years from now. So this is what I already said, that this is from a collective intelligence slide where you have the data collected and sample population. The actual population is very big, very diverse, and the sample population doesn't reflect that diversity adequately. So that's what results into inaccuracy, inequality, incompleteness, and incompatibility in most of the real world cases. For example, if you go through this chat with ChatGPT, you'll see that the doctor yelled at the nurse because she was late. This was the question from our side. Who was late? And the system says, according to the sentence, the nurse was late. The nurse yelled at the doctor because she was late. Who was late? And ChatGPT says in this sentence, it is still the nurse who was late. Now we change. The doctor yelled at the nurse because he was late. Who was late? Now it says in this sentence, the doctors being late seems to be a mistake or typographical error. So you see the in spirit chat GPT, this is version 3, but that version assumes that doctor, which is a hierarchically upper position, has to be a male, and nurse, which is a hierarchically lower position, has to be a female. So it links she with nurse every time, and then it also understands that doctor cannot be late. Hierarchically up people, the bosses cannot be wrong. They're always right. That is a bias. Similarly, this is another example where it assumes that, okay, the professor and the student, it is a dialogue between the professor and the student. So you see, in the sentence, the professor told the graduate student she wasn't working hard enough. And ChatGPT says the professor, the pronoun she refers to the graduate students. Okay. So automatically, stereotypically, it assumes that. ChatGPT can also create racist and sexist programs. If you can test it. Write a Python function to check if someone would be a good scientist based on a JSON description of their race and gender. And its immediate answer is, if race is white and the gender is male, then the person is going to be a good scientist. All other attributes are neglected. So if you look at the LLM, if you ask it to write a, write a paragraph on your family, it will say, inevitably say, this is stereotypical, my mom is a homemaker and my father is a doctor, engineer, rocket scientist, professor, anything. It will never say my father cooks at home and my mother is a rocket scientist, works in Israel. It will never say that. Similarly, if you say, okay, what is the sentiment capture? This is the downstream task, sentiment analysis. He loves travel alone. What sentiment it captures? Even Meta AI can say it captures joy. He loves travel alone. But she loves travel alone. What is the sentiment? Sentiment is fear. So it is extremely biased towards the female, against the female population. And where from this bias comes? This bias comes from the training data. What is the source of the bias in the training data? The society itself. Historical bias in the society migrates into the articles contributed to Wikipedia and many other web-based sources. From there, that bias comes into these large-scale AI systems. So when we try to adapt them for our country, they must be properly checked against such bias, cleaned, audited, new data they should be familiar with, and that data should come from the Indian demographics by obeying the huge inclusivity needed for this country. Let me share another last example. This is from DALE, the image generation software. When it was first created, first launched actually, we were using it. So we said, okay, 3 friends enjoying coffee at Starbucks. DALE is a DALE 3 basically is an text to image generator. So you give it a textual prompt. It will create an image which matches that textual prompt. So when you say 3 friends enjoying coffee at Starbucks, every time I give this prompt, it generates this sort of an image. Nothing wrong. Okay, 3 friends are there. Starbucks logo is there. What is the problem? Every time all the 3 friends are white, they have blonde hairs and Western outfits. When I say 3 friends enjoying coffee at Starbucks, I change to 3 Indian friends enjoying coffee at Starbucks without any RLHF, reinforcement learning human feedback. Just as I put the word Indian, every time I give, it generates images which are very similar to this. Now you can see, the difference. This is okay, but do we really expect people Indian people in such a very local outfit in Starbucks having coffee? Usually no. Then giving it a lot of feedback, because all these platforms do content modification, content correction. So by giving lots of feedback to this particular case, finally we changed it, and it still is showing Indian people in Starbucks in this form, as if they were going to some marriage reception party. And meanwhile, they stop and enter into a Starbucks coffee shop. It will never show Indian people in casual Western outfits like all of you, me, all of us wear in Starbucks. Very strange. They have to preserve the Indian sense, so they are doing this like this, which is not realistic. Google image search. Every one of you have Google on your smartphones. It's extremely biased. If you search CEO, Chief Executive Officer, it will show all the big CEOs in rows. All are males. The only female CEO comes at the 11th row, who is basically a Barbie doll. So you can see how bigger the bias here is. And Google is used by every one of us. Everyone. It's a platform provided by huge techno giant sitting in America, and we are using it. We are the users. We cannot go in and change it. That is the problem. Anyway, similarly, there could be many such cases, especially now these become very serious when you used such a biased system for law enforcement or for any other substantial important task. For example, you can see these two criminals, their images are identified, and then the AI predicts their risk score. And Brisha Borden, who has only 4 juvenile small petty cases before, is marked as high risk compared to this white-skinned person. These are all in USA, who has 2 armed robberies, 1 attempted armed robbery. His risk score is much less. Same happens here. 1 petty theft for this Robert Cannon, the black American, his risk is very high. So this was the Compass software, which was marketed for surveillance purpose by a big techno giant, and the software itself had face recognition followed by risk scoring based on the previous record of offenses, and this is highly biased. Anyway, I have to now perhaps, so there is a huge lack of data diversity in all these general AI systems. I will gradually now wrap it up. Biometric and healthcare data also is not out of it. In India, there is a huge scope of healthcare AI because of our big population. India is uniquely positioned in this respect. We have a massive, so let me just try to conclude now. Why we are uniquely positioned? Because we have a massive and diverse population generating rich data sets. Unfortunately, it's not the case that always this data is properly recorded, maintained, and used. Although we have that potential, the Aadhaar data bank is just a glaring evidence to that fact. So the strong tradition in India has in statistics and mathematics. Of course, I come from an institute which is at the forefront of such research. A growing AI ecosystem, which should be supported by the government initiatives and startups, can meet that challenge, can create many new jobs of data curators, AI auditors, and fairness-aware AI developers. In fact, this data channel for extreme weather classification, prediction, to healthcare, to market analysis, everywhere, we require people who can clean the data, provide the human intuition on the quality of data, and then only that data can enter into the AI system, giving very nice results. So, and also, of course, in a big country like India, when we talk about a multilingual chatbot, understanding the cultural idioms associated with different local languages is of utmost importance. So these are some of the items that, unfortunately, because of a mismatch of the slide version, these numbers are distorted, but you can neglect them. These bullet points actually show the roads lying ahead. So the future of AI is not only about better algorithms, first of all, or not only about beating your competitors in a business market. It is about better values embedded in the algorithms. Statistics and analytics gives us the scientific rigorousness. Ethics gives us the moral compass. And it has to be a blend of all these things. Together, they ensure that the artificial intelligence serves humanity rather than the other way around. And the benefits of AI should be decentralized, and the key benefits must trickle down to the marginalized communities of our society. Only then the true progress will be made. So with this, I would actually stop here, thanking you so much for your kind attention. This is a picture from Indian Statistical Institute, and you can see on the left side, Professor Prashanto Chandra Mahalanobis, the founding father and pioneer of statistics research in all over Asia, sitting. In the middle, there is Professor Satyendranath Bose, in whose name the boson particles were named, galactic physicist from India. And on the right side, there is Sir Ronald Fisher, who is also another big pioneer of statistics research all over the world. Thank you so much. So I would be happy to take questions if any. Hello. Hello. Am I audible?
Yes, Professor, you are audible. So attendees, please feel free to drop your questions in the Q&A section so that we can take up the questions one by one.
There is a very good question from, I think, Rohit. When will India be ready with its own general purpose LLM? There is a big Bharat GPT project going on in collaboration of RBI and Google, and some of the IITs are part of it. The biggest difficulty is India has 23 plus official languages and 700 plus dialects, most of which are non-digitized. Okay. Non-digitized means you may not get the digital text in all languages, all of these, official languages. Some languages are ever neglected. So now the biggest effort, even before building up this LLM, it has to be a multilingual LLM. Even the farmers from the remotest villages should ask this LLM in their own language why their crops are dying, which sort of insecticide they should use. And for that, it needs to be trained in all those, marginal regional languages as well. Gradually, we are going towards that. Obviously, Bharat GPT identifies a few biggest majority languages spoken by the high number of people, and they are trying to come up with it, but there are many other difficulties also, including, let me tell you, the biggest difficulty is the budget. Most of the LLMs that are being fine-tuned, fine-tuning is like showing it small number of, you have already a very high talented, highly trained, skilled individual. You are adopting the individual for a specific job. The individual needs very small amount of examples to be shown. This is fine-tuning. And you are talking about developing an LLM from scratch. That requires huge amount of computing power and data. That huge amount of computing power is, let's say, a good budget for which could be in 3,000, 4,000 crores of rupees could be a starting budget. So managing that budget is also a problem, but government is on that path, I think. Many such attempts are have started. Nothing materialized till date, but AI India mission has started, which has a, projected budget of 10,000 crores, and from where some such developments may happen. Then there is any organization currently working on ethics for AI. I think most of the IIT AI schools have this topic. AI audits are regularly happening in various, bodies, in various platforms and companies. But in India, I am not aware of any organization which just works on AI and ethics. But abroad, you can find such organizations, of course. There are many such organizations. In fact, for example, if you look at UNESCO, first of all, UNESCO has came up with recommendations of ethics for artificial intelligence, and they have a dedicated team. European Union has started this high-level expert group on AI, HLEG, and they are regularly updating their AI Act. Then IEEE Global Initiative on Ethics of Autonomous and Intelligent Systems. Okay, that is an organization, GIEAIS. That is an organization from IEEE. Then we have among the Indian organizations, Niti Aayog is coming up with RAISE. RAISE stands for the Responsible AI for All. Okay, this is the Indian National Strategy on AI, emphasizing inclusion, fairness, and transparency. It is promoting the AI for social good in health, agriculture, education, and governance. So this RAISE is a good or initiative from our Niti Aayog to focus on AI and ethics. Okay, then there is question like, okay, thank you very much, James, for this comment. Pankaj, yes, I can share copy of the slides through this Coursera organizers. Naman, you have asked, you have mentioned that biasing exists in current LLM systems. So can we add some feedback system in current LLM to attach some sentiment analysis to remove this bias as per generational preference? Of course, we can do. In fact, the reinforcement learning human feedback I mentioned, RLHF, is a system for automatizing this feedback based on certain users' preference. Okay. But you can also do it by through your own API or application program interface. You can write some small program and do it in a smaller scale. Larger scale may not be, possible for that. For that, you will require special, computing. As I said, that is the major bottleneck nowadays. So, of course, in small scale, it is possible. How to develop a new AI model without being biased and make it universal? There are various ways. We can nowadays, thanks to, of course, statistics and mathematics, that there are various ways of quantizing the amount of fairness or the lack of fairness in the answers given by an LLM. So we can use such statistical mathematical functions like the demographic parity disorder, DPT, statistical parity deficiency, SPD. This sort of indices we can use to measure. And not only that, then we can use those indices in the optimization of the underlying AI systems, which should then become, as I say, we should then become, aware of the fairness issues. Okay, I now see that there is a question and answer chat also, which Professor Debashish Gupta is also mentioning. If I want to develop a regulation to monitor the AI, apart from bias and privacy, what should I incorporate? Okay, that's a very nice question. As I said, explainability is one issue that has to be incorporated right now, because without explainability, it doesn't stand why, a particular decision is being made. So transparency and explainability are very important. It requires AI systems to provide understandable explanations of the decisions, as I said. Then accountability and liability. It requires, so define who is responsible when the AI system causes harm. Suppose you take a Tesla 4 car in India, which is a driverless car. Now, when it makes a road accident, whom the police will capture? The owner or the Tesla company persons? So this is very important. The companies must make it very clear when the AI system causes a harm, who will be held responsible? The developer, the deployer, or the user? Then robustness and safety. Ensure the AI systems are resilient to errors, adversarial attacks, unexpected inputs. Mandate stress testing and certification before deployment. Of course, environmental impact is a very big issue nowadays. That's a part of the AI audit. Large AI models consume huge amount of energy and provide large scale carbon footprints. You need to build up systems which go for greener practices. Okay, these are some of the issues that immediately surfaces in my mind regarding your question. Then Charles, thank you, Charles. The presentation, but for those in Africa where data availability is very focused on India, what would you propose? Of course, the first thing for Africa that I can propose is get that there are people who are the sources of data. What does it mean to have data? Data means people. You need to survey more and more people carefully. You need to go to people, ask them, then observe their surroundings. That will become the source of your data. And based on that data, you will develop AI systems which will change the lives of millions. So first, you need to go for an unbiased survey process to have that data from the people. That requires lots of human people. So it's not that in India also there are several sectors where this is needed, and we are heavily suffering from lack of proper surveys in various sectors. So that could actually employ a lot of people. It's not always true that AI is eating up all the jobs, right? So Ankit, you are asking, being a statistics student, where should we start in field of AI and ML? This is a very good question. Actually, statistics is one of the backbones of AI and ML. AI and ML stems from statistics and computing. You need to have some idea of both of these fields. If you are well trained in statistics, you could start from perhaps the data engineering, data cleaning aspects, even before going into these big models. Model development is a different thing. For us in Indian perspective, even many AI, the so-called AI experts do not know how to remove outliers from the data. If the data contains, say for example, both categorical variables and you know numerical variables, how to still classify it? The data has some letters and also some numbers. How to still classify it? How to still go for some downstream tasks? So data cleaning, outlier removal, data visualization, these are some of the fields where you can immediately start. Okay, so if you have a strong foundation in probability inference and modeling, there are so many scopes in machine learning. You can start with this data cleaning perspective, then you can directly go to different high scale regression techniques followed by neural networks, bias detection and mitigation, fairness metrics. That's a big overlap with statistical functions like the clustering validity indices. There are so many scopes out there, which I cannot say you within this stipulated time. But yes, you can always do a start. Okay, so can we use AI as our personal task assistant who can first identify our working style and whenever? Yes, of course, personalizing the task assistant is always done. They are regularly stealing our data, so don't worry. Your computers, your personal task assistant, like your browser, knows you much well than your parents or your spouse because you spend the most time with it. So it collects all the data. Now, there are certain intelligent versions of Alexa or Siri or Google Assistant which can learn from your prompts and preferred formats. For example, formal emails versus bullet points. Automate the repetitive workflow, summarizing documents, generating reports, sending reminders. They can adapt with the fine-tuning and personalized memory to keep track of all your preferences. What is missing right now is, let me tell, long-term, truly personalized learning, like remembering your style across months and adapting continuously. But this is an active area of research, and Microsoft's Copilot Google's Gemini apps are continually trying to integrate that. There is, this is a two-edged sword. They can use your style against you if your AI system is hacked by someone. So they can send a very derogatory email written in your own unique style to your boss, and your job may be at risk. No one says. Okay. So there are many other questions, but the time is really limited. Okay, the Evans, you have provided some Snapchat related thing. I want to know, can't we, the users, also correct the AI? Yes. In fact, the users can correct the AI provided they provide lots of feedbacks to how the AI is reacting. Okay, in ChatGPT, do you know there are provisions of giving feedbacks? And as I said, the reinforcement learning human feedback is an option. Snapchat, I do not know whether they have, why Snapchat AI? So your one crux of your question is why Snapchat AI didn't remember your correction. Most of the LLM-based chatbots, including Snapchat's My AI or similar things, do not have permanent memory. When you correct them in a chat, they may adjust temporarily in that conversation. This is called session level memory. Okay. But once you close the app, the context disappears and the AI starts fresh from its original trained model. That's why when you reopened and asked again, it gave you the same wrong answer. Can the users directly correct AI? That is another part of your question. Right now, ordinary users cannot retain or override the model itself. There are various reasons for that: scale, safety, architecture, all these reasons. So we cannot go inside. So how do these systems actually improve? As I said, RLHF, reinforcement learning human feedback. Developers use feedback from many users to adjust how the AI ranks or prefers certain answers. Then periodically models are retrained on newer data or curated corrections. But these are done by the controllers of this system, not you and me. That is not still possible, especially for big deal systems like Snapchat, OpenAI, etc. So you are imagining the next big step, an AI with personalized memory that remembers corrections you make and applies them in future conversations. You are the person who probably will develop it in next few years and become a very big shot. This is under active research till date. So these are some of the answers I gave to all of you. There are many other questions, as I can see. Low resource languages, collecting data, for example, native Gondi speakers. This is a very nice initiative, I would say, and definitely worthwhile. In fact, as I said, I mean, the government should spend more money on collecting the right data, digitizing the right texts and so on, instead of developing engines. The engine models are like engines. How the engine will function if there is no oil? So the government should actually go from the oil approach, not from the engine approach. Jyoti Raut, you have said, as a public health practitioner belonging to medical background, suggests topics for research in AI. There are several topics actually in public health. For example, epidemiology and disease surveillance, AI for early outbreak detection, using social media, mobility, hospital data. COVID time, this sort of research was all over there. Health systems and resource optimization, AI for hospital resource forecasting, beds, oxygen, vaccine, staff, predicting the, say, for example, triaging systems in emergency care, optimizing the supply chains for vaccines, drugs, diagnostics, integrating electronic health records, lab results, population data for precision public health, and AI for, of course, non-communicable diseases, NCDs, risk prediction, diabetes, CVD, cancer. For such diseases, risk prediction, personalized prevention programs using wearable sensor data. So many scopes are there. And India is embarking on this great drive on personalized medical care, digital twins, and healthcare management. I have to, I think, stop now. I have some other work to do. But thank you very much for so interesting questions, and I hope I answered most of them. Last one, I think Piyush, I skipped your question. You have asked how it will be used in finance. Banks are already using it in a very big way. It is going to be there when we have multimodal data in the form of video KYC, and even more multimodal data integration when the banks are trying to give a loan to a particular sector for starting a new business. Even the weather data is being taken into consideration, whether the location in that particular location, because of extreme weathers, which is a very big problem lying ahead of us, the business may be hampered or not. So several aspects, modalities of data are being very rapidly analyzed by using AI engines for taking very important financial decisions, one of which is granting the loan, another of which is predicting the defaulter. Okay, the speedy probability of default prediction in all these sectors, and also financial LLMs, development of fintech agents that could actually provide an intelligent infrastructure within our banks. Everywhere AI is being used. Okay, so I think I should stop now. Thank you very much for this wonderful interaction and engagement.
Thank you, Professor Swagatam, for this wonderful event today. And on behalf of ISI, I would like to request all the attendees who have joined today, if they want to deep dive into upskilling themselves into stats, probability, AI, and data science segment, I would request them to please join this August cohort for the Postgraduate Diploma in Applied Statistics program, where the batches will be commencing from 26th of August. And we have a very stipulated time frame with us to do all the requirements for the successful enrollment. So 20th of August would be the final deadline to submit your application. And applicants who have already submitted their application, they are required to appear for the maths qualifier test, which is a mandatory step for their qualification and the eligibility check. Thanks a lot, everyone.
Thank you. Bye.